I've always been intrigued by the concept of a site-to-site VPN. I mean, it's amazing. You have two sites, site one and site two, and if they send traffic, or their users send traffic between those two sites, the edge devices, they take that traffic, they encrypt it, ship it over logically the VPN tunnel, protected, and the other side receives it and unencrypts it and forwards it on its way. It's amazing. So what I'd like to do in this video is take you behind the scenes on how a site-to-site knows what to do and some of the configuration options available for it. So using this topology, let's talk about some of the ingredients that might go into a site-to-site VPN. For data confidentiality, we're going to be using some type of encryption algorithm. For data integrity, we're very likely using some kind of a hashing algorithm or set of rules. And then we can train these two routers, router 1 and router 2, that they are going to be peers, that we're going to set up a VPN or a security association between them. Now, a really good question to ask is that to set up a site-to-site VPN tunnel between these two routers, what are we actually using for the umbrella of the hashing and encryption algorithms that we're going to be using? And the technology we're going to be using is called IPsec, capital I, capital P, SEC. Meaning or implying that we're going to provide security for each individual IP packet as it gets transmitted between the two VPN peers. So we'll be using IPsec. Now, one great question is, how can a technology like IPsec, how does it stay current? Because I was learning about IPsec like 30 years ago and it's still around. So how is it still current and viable? And the answer is IPsec is like an umbrella. It's a collection of protocols and utilities. And as new protocols come up, IPsec can adopt those. So long time ago, we had encryption protocols like DES, the data encryption standard, and then triple DES, which was even more secure. And now we're using AES. And as we have new encryption standards, we simply start to not use the older ones. So IPsec over the years has the ability to use any of these encryption standards. And as they get better and better, IPsec will adopt them. Also, we have some evolution in the world of IPsec. There was a thing called IKE. Originally, we had IKE version 1. IKE stands for Internet Key Exchange. There will not be a test on that later. But IKE v1, and as time went on, we have IKE v2. And either one of these methods as part of IPsec can be used along with the encryption and hashing algorithms to provide security as traffic is traveling between R1 and R2. So what I'd like to do right here with you is take a look at what happens between the two VPN devices that want to establish a tunnel, a security association between them. I want to share with you what happens with IKE version 1 behind the scenes. And here it is. These routers would be configured, and what they would do is they would set up and they would negotiate what's called an IKE phase 1 tunnel. This IKE phase 1 tunnel is being used so that R1 and R2 can securely talk to each other. So if they need to communicate directly to each other, they can send the data logically into the encryption and hashing algorithms that are part of the phase 1 tunnel. This is also sometimes called the ISAKMP SA. Now, ISAKMP is an acronym. You don't need to memorize the acronym, but it's an acronym for the Internet Security Association Key Management Protocol. And SA is an acronym for Security Association. So they'll build this tunnel, and for this tunnel, they'll have negotiated and agreed upon things such as which encryption algorithm are we going to use, what hashing algorithm are we going to use, and also the keys involved. They can negotiate keys dynamically so that only R1 and R2 have the ability to lock and unlock the data respectively. And after R1 and R2 establish this tunnel that they can use to communicate with each other, they then go to work and they build a second tunnel. What, Keith? A second tunnel? Yeah, they build a second tunnel, and that's for users traffic, like Bob. So if we put Bob over here, and we put Lois over here, for the actual traffic from users at site 1 going to site 2, when that traffic hits the routers are going to encrypt that user data and ship it logically over the tunnel to the other side, who will then decrypt it and forward it on to its intended destination. And this second tunnel is often referred to as the IPsec SA, or we could also call it the phase 2 tunnel. And it's not likely that in one given sentence they're going to refer to either of these tunnels by all of their possible names, but I wanted to share with you where they fit. And for this IPsec tunnel, which is going to be used to encrypt the user's traffic going back and forth, they will also, the router 1 and router 2 will also have negotiated what type of encryption they want to use for that tunnel, the hashing that they want to use for that tunnel, and other parameters that are applicable, including what traffic to encrypt. I mean, if this is the site 10.16.0 and over here is 10.16.8, part of the rules for the tunnels would say, okay, only encrypt traffic if it's coming from 10.16.0 and going to 10.16.8. So if Bob's trying to go to ESPN or some other website or Twitch or whatever, when the router sees that traffic, he'll look at the source. It's coming from 10.16.0, but it's not going to 10.16.8, and as a result, it can do a NAT. It's probably going to use NAT at that point, and then forward it out to the internet and not send it through the tunnel. So in this video, we've introduced the concept of IPsec, which is a huge umbrella that covers a lot of sub-technologies, including hashing algorithms and encryption algorithms. We also identified that two routers that are running IPsec, they are going to establish relationships with each other. We call those security associations. And as part of that, they're going to negotiate the encryption they're going to use, the hashing they're going to use, and depending on the version or flavor of IPsec and the site-to-site tunnel, we could have an IKE Phase 1 tunnel, where the two routers are just talking to each other directly, and then a second tunnel, a logical tunnel, that's going to be used to encrypt and send the traffic from users like Bob and Lois back and forth, encrypted, safe, and private over that tunnel. And what I thought would be fun to do is, let's take a look with a network analyzer to look at the actual packets, and we'll take a look at what the packets look like before they're encrypted and after, just to verify that traffic that is going through the tunnel, that those packets are being encrypted and protected and shipped over to the other side. So I'll see you in that video in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.